Chapter 5.1, Graphing Sine and Cosine Functions. A periodic function repeats itself over regular intervals, called cycles, of its domain. Trigonometric functions are periodic, or cycle. A sinusoidal curve oscillates repeatedly up and down from a center line. Sinusoidal just means a sine curve or a cosine curve. Period. A period is the horizontal length of the interval of the domain that repeats. The period of the graph is the horizontal distance required to complete one cycle. So we can see here the graph starts at y equals 0, goes up to y equals 1, comes back to y equals 0, goes to y equals -1, comes back to y equals 0, and then it starts to repeat that pattern. So the period is the horizontal distance of one cycle before it starts to repeat, which in this case would be 2 pi. We can also look at the period from one minimum to the next minimum, or from one maximum to the next maximum. Amplitude. The amplitude is half the distance from the maximum to the minimum. This is the distance between the midline and the maximum. Amplitude is always positive and can be found by the following formula. Amplitude equals max minus min value divided by 2. A note here, this is not on the formula sheet. So you either need to memorize this formula or just know that amplitude is the distance between the midline and the maximum, or the midline and the minimum. And amplitude is always positive. If we have the equation of the function, we can also get the amplitude, because amplitude is the absolute value of the a value in the function. So absolute value of a. Let's look at this table. We have the function y equals sine x. The period is 2 pi. The amplitude is 1, which is our a value. We would have 1 sine x. The specified domain in this case is between 0 and 2 pi. And the range is from -1 to 1. Next one, y equals 3 sine x. Our period is still 2 pi. Our amplitude now is 3 because the a value is 3. The specified domain is the same, from 0 to 2 pi. And now notice the range goes from -3 to 3 because our amplitude is 3. So from our midline of y equals to 0, we go down 3 to get to the minimum and up 3 to get to the maximum. Next one, y equals 0.5 sine x. Period is still 2 pi. Amplitude is now 0.5. Our domain is the same. Our range is now from -0.5 to 0.5. And then y equals -2 sine x. Period is 2. The amplitude is 2. The absolute value of -2 equals 2. Our domain is the same. And our range is now from -2 to +2. So we can see how the amplitude affects the range. We can write a note for functions where k equals 0, which means there is no vertical shift. The range is y such that negative absolute value of a is less than or equal to y is less than or equal to absolute value of a, y, e, r. This only works for functions that don't have a vertical shift. Once we've vertically shifted up or down, then our midline changes, so that's going to change our range. But if our k value equals 0, so we have no vertical shift, the range would be greater than or equal to the negative amplitude, which is the negative of the absolute value of a, and less than or equal to the amplitude, which is the absolute value of a. The sine function. Y equals sine theta. We have a table here that shows us the value of sine theta at different angles in both degrees and radians. Remember that sine theta is the y value of points on the unit circle. Characteristics of the sine curve. The curve is periodic, which means it repeats. The curve is continuous, which means it keeps going. The domain, if it's unrestricted, is theta such that theta is an element of the real numbers. So all values for theta. In the range, on our graph here, we have a maximum at y equals to 1, and we have a minimum at y equals -1. Then our range for y equals sine theta is y such that -1 is less than or equal to y is less than or equal to 1, y-er. The maximum we just saw is 1, and the minimum is -1. The period, how long until we start repeating? If we look at our graph, it starts at 0, goes up to y equals 1, goes down to y equals 0, goes down to y equals -1, and then goes up to y equals 0, and then from this point it would start repeating. So our period would be 2 pi. Or in degrees, 360 degrees. The amplitude, from the center line to get to the max, we go from 0 to 1, so that's an amplitude of 1. Or looking at the min, from the center line, we go down 1 to get to our minimum of -1. So our amplitude is 1. The theta intercept in radians, so this is like the X-intercept. The X-axis, when we're graphing trig functions, represents the angle measure. So the theta intercept in radians, we have one at 0, one at pi, one at 2 pi, and so on. So they're every pi. So we can write 0, pi, 2 pi, etc. But to write all of them, we need to write it in a general form. So we have 0 plus, they happen every pi radian, so 0 plus pi n, where n is an element of the integers, or pi n, where n is an element of the integers. Either one of those. And then the theta intercept in degrees, same idea. On the graph we have 0, then 180, then 360, and so on. It's going to continue on forever. 0, 180 degrees, etc. So to write that in general form, we would have 0 degrees plus 180 degrees n, where n is an element of the integers. Or we could write that just as 180 degrees n, where n is an element of the integers. And then the y-intercepts for y equals sine theta, it is at the point 0, 0. So the y-intercept is the point 0, 0, or y-intercept is 0. The cosine function. Sketch the graph of y equals cos theta for 0 is less than or equal to theta is less than or equal to 360. So recall that cos theta is the x value of points on the unit circle. Let's draw a unit circle. Let's find the value of y equals cos theta at different angles. So here at 0 degrees, our coordinate point would be 1, 0. Cos is the x value. So cos of 0 degrees equals 1. You can plot that on our graph. At 0 degrees is on the x-axis. We have a y value equal to 1. Then this point here, which is 90 degrees, the coordinate point on the unit circle is 0, 1, which tells us that cos of 90 degrees equals 0. The x value at that point is 0. So at 90 degrees on our graph here, 90 degrees would be here, halfway between 0 and 180. Our y value is 0. So we're going to put a point right there. And there we go. Look at the next point at 180 degrees. We have the point -1, 0, which tells us that cos of 180 equals -1. So at theta equals 180 on our graph, go down to y equals -1 and put a dot. And then at theta equals 270 degrees, we have the point 0, -1. So this tells us that cos at 270 degrees equals 0. Find that point on our graph. 270 is halfway between 180 and 360. We have cos of 270 equals 0. So we get an x-intercept or a theta intercept at that point. And then if we go back to 360 degrees, we have cos of 360 would equal 1 as well. So at theta, at x equals 360 degrees on our graph, we go up to y equals 1 and we put a dot. And then we know that sinusoidal functions are curves, so we want to join these points together not with straight lines, but with curves, being 1 is our maximum, come down, -1 is our minimum, and it'll look something like this. In this case, the domain is what they told us right here. So x or theta, doesn't really matter. 0 is less than or equal to x, which is less than or equal to 360 degrees. XER. Our range goes from -1 to 1. Y such that -1 is less than or equal to y, less than or equal to 1, YER. The maximum value, y equals to 1. The minimum value is when y equals to -1. The period, you can see that in this domain we have one full cycle, and then from this point it's going to start going down again and repeating that cycle. So our period would be from 0 to 360, which means it's 360 degrees. Or 2 pi if we were in radians. The amplitude is 1. We go from the midline, we go up 1, or from the midline, we go down 1 to get to our minimum. So our amplitude is 1. The x-intercepts are at 90 degrees and 270 degrees. Or if we were talking radians, that would be pi over 2 and 3 pi over 2. And our y-intercept is at x equals 0, y equals 1. So there's the basics of the graphs of our sine and cosine functions. On the same set of axes, graph y equals 6 cos x and y equals negative 4 cos x for x greater than or equal to 0, less than or equal to 2 pi. What is the amplitude of each graph? Remember that the amplitude is equal to the absolute value of the a value. So for y equals 6 cos x, the amplitude would equal 6, absolute value of 6 is 6, and for y equals negative 4 cos x, the amplitude equals 4. Absolute value of negative 4 is 4. This tells us that our y values need to go up to 6 and down to negative 6. So 1, 2, 3, 4, 5, 6, and negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Then we want to determine the intervals on the x-axis. This is where our angles are. We're going from 0 to 2 pi in our domain here. So we want to count in terms of our special angles. We have pi over 3, pi over 6, pi over 4, pi over 2. We can count in any of those. And we always want to make our graph take up as much space on the given grid as possible. So if I counted by, let's say, pi over 2, if this was pi over 2, and 2 pi over 2, 3 pi over 2, 4 pi over 2. 4 pi over 2 is 2 pi, so my domain of 0 to 2 pi would only go up to here. That's not taking up very much, so I don't want to count by that. What I want to do is try to count by the smallest increment I can. So let's try pi over 6. 2 pi is equivalent to 12 pi over 6. So let's count 12 increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That takes up most of our graph, so that's a pretty acceptable amount. Let's plot 2 pi right here. If that's 2 pi, then 6 units would be pi. 1, 2, 3, 4, 5, 6. So this will be pi. And then halfway between 0 and pi would be pi over 2. And halfway between pi and 2 pi would be 3 pi over 2. Okay, so now I want to draw my graphs. I'm going to start by plotting the regular cos function, y equals cos x. So remember that cos is the x value of points on the unit circle. So let's draw a unit circle. At 0 radians, we have the point 1, 0. So this tells us that cos of 0 radians equals 1. We can plot that on our graph. At radians equals to 0, our y value equals to 1. So we have a y-intercept there. Then at pi over 2 radians, we have the point 0, 1. So this tells us that cos of pi over 2 equals 0. On our graph, we find pi over 2 on the x-axis and y equals to 0, so on the x-axis it's an x-intercept. Then we go to pi radians. That gives us the point -1, 0, which tells us that cos of pi equals -1. We find pi on the x-axis of our graph, and we go down to -1. Next, at 3 pi over 2, we have the point 0, -1, which tells us that cos at 3 pi over 2 equals 0. We plot the point, we find 3 pi over 2 and y equals to 0 on our graph. I'm going to change these colors so they stand out more. Purple here. And then last we get back around to 0, which is now 2 pi radians, and we have cos of 2 pi equals 1. We go to 2 pi on our x-axis, and we go up to 1 on our y-axis, and we plot our point. Then we have a curve that goes through these points, so it's going to look something like this. And that's our y equals cos x. Next, we want to graph y equals 6 cos x. Using transformations, our a value is a vertical stretch factor, so we take the y values at each of our points for y equals cos x and multiply them by 6 to graph y equals 6 cos x. That gives us, at the first point, when the angle is 0, the y value is 1, multiply that by 6, we get, when the angle equals to 0, the y value is 6. When the angle is pi over 2, y equals to 0, multiply that by 6, you still get 0, so at an angle of pi over 2, we still have an x-intercept at 0. When the angle is pi, cos of pi equals -1, multiply that by 6, we get -6. At x equals 3 pi over 2, we have cos 3 pi over 2 equals to 0, multiply 0 by 6, we still get 0. And then at 2 pi, we have cos of 2 pi is equal to 1, multiply that by 6, and we get 6 cos 2 pi equals to 6. Then we join those points together with a curve. And we get something like that. Doesn't look perfect, but that's okay. Y equals 6 cos x. Now we do that same process for y equals -4 cos x, but we multiply our y values by -4. The first point here, we have a y value of 1, multiply that by -4, and we get -4. So at an angle of 0, -4 cos of 0 gives us -4. Then at pi over 2, cos of pi over 2 is 0. Multiply that by -4, we still get 0. So -4 cos of pi over 2 equals 0. Then when our angle is pi, cos of pi is -1, multiply that by -4, and we get +4. When our angle is 3 pi over 2, cos of 3 pi over 2 equals 0, multiply that by -4, and we still get 0, so that's also an x-intercept still. And then when our angle is 2 pi, y equals cos of x is 1, multiply that by -4, we get -4, so we'll have a point here at -4. Then we join those points together with a curve. And there we have y equals -4 cos x. Compare the graphs to y equals cos x and consider the period, amplitude, domain, and range. The period, they all have a period of 2 pi. Cos does 1 full cycle and then would start again heading down after 2 pi. 6 cos x also does 1 full cycle and then after 2 pi, it would start heading down and repeating, and negative 4 cos x does 1 full cycle from minimum to minimum. After 2 pi, it would start heading back up and repeating. Same for all of them, and it is 2 pi. The amplitudes are different. For y equals cos x, it's 1. For y equals 6 cos x, it's 6. And for y equals negative 4 cos x, it is 4. The domain is the same for all of them, and it's just what we were given. X such that 0 is less than or equal to x less than or equal to 2 pi XER. And then the range is different for each of them because the amplitude is different. So for the first one, cos x, we have negative 1 less than or equal to y less than or equal to 1. Then for 6 cos x, we have negative 6 less than or equal to y less than or equal to 6. And for negative 4 cos x, we have negative 4 less than or equal to y less than or equal to 4. What is the amplitude of y equals 1.5 cos x? Well, a equals 1.5, and the amplitude equals the absolute value of a, which equals the absolute value of 1.5, which equals 1.5. In the following examples, determine the period from the graph or from a formula. The formula for period is 360 degrees divided by the absolute value of the b value from the function. Or in radians, period equals 2 pi divided by the absolute value of the b value from the function. Recall that the b value is inside the function. It's what's being multiplied to the x value. This is also not on the formula sheet. But you need to know it. So looking at the graphs, y equals sine x starts at 0, 0, goes up, goes down through 0, goes back up to 0. That's 1 full cycle. At that point, it would continue going back up and down, so it's repeating. So our sine and cosine functions, the base functions y equals sine x and y equals cos x, have periods that are 360 or 2 pi. Let's look at sine of 4x. We start at 0, 0, we go up, come back down, and go up back to 0. Then from this point, we're repeating up, down, back to 0. Repeating up, down, back to 0. So this point here is 1 full cycle, which takes us from 0 to 90 degrees. So that's a period of 90 degrees. So then period is 90 degrees. Doing this using the formula, we would have P equals 360 degrees divided by the absolute value of the B value, which in y equals sine 4x is 4, which gives us 360 degrees divided by 4. 360 divided by 4 is 90 degrees. Taking a look at the next one, which is in radians, we have y equals sine x in blue. We see that 1 full cycle go up, go down, and back to 0 is at 2 pi. So here our period is 2 pi. For the next one, start at 0, 0, we go up, down through 0, down to a minimum, then back up to 0. That's one full cycle. After that, it'll continue going up and then down, so cycling again. So this time it's 4 pi. Four pi is one full cycle, so P equals 4 pi. Calculating that with our formula, we would have P equals 2 pi divided by the absolute value of B, which in this case is 1/2, which gives us 2 pi divided by 1/2. Dividing by fractions, we multiply by the reciprocal, so 2 pi times 2 over 1, which gives us 4 pi over 1, or 4 pi. Sketch the graph of y equals cos 3x for 0 degrees less than or equal to x, less than or equal to 360. State the period of the function and compare the graph of y equals cos x. Our domain is from 0 to 360, so to determine my scale for my x-axis, I want to try to take up as much space on this graph as possible, and I want to count by one of our special angles, so 30 degrees, 45 degrees, 60 degrees, 90 degrees, one of those. I'm just going to test it out if I count probably by 30 because I have quite a bit of space here. So let's count by 30. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. So that takes us to here. So let's count by 30s, put our 360 degrees there. Then I can mark some other points along the x-axis. We had 30, 60, 90 would go here. 120, 150, 180 would go here. 210, 240, 270 would be here. And then I need to know what my amplitude is so I can determine how high up I need to go on the y. I have y equals cos 3x. The a value would be 1. So our amplitude is 1, which means we need to go up to +1 and down to -1. So I'm going to go up by 0.5 so that the second line is 1, just so it's not so cramped. And then going down the second line below would be -1. I'm going to start by graphing y equals cos x. Remember that cos is the x value of points on the unit circle. Draw my unit circle to help me find some points. At 0 degrees, we have the point 1, 0, which means that cos of 0 degrees equals 1. So at 0 degrees, 0 for our x-axis, we go up to 1 and plot a point. Next point is at 90 degrees. We have 0, 1, which tells us that cos of 90 degrees equals 0. On our y-axis, go to 90 degrees and plot a point on the x-axis since y equals 0. Next point is at 180 degrees. We have the point -1, 0. This tells us that cos of 180 degrees equals -1. On our graph, locate 180 degrees on the x-axis and then locate -1 on the y-axis and plot a point. And then we have angle 270 degrees, which is the point 0, -1, which tells us that cos at 270 degrees equals 0. Find 270 degrees on the x-axis and plot a point there where y equals to 0. Then we get back around to the 0 angle, which is also 360. So we also have that cos of 360 degrees equals 1. Find 360 on your x-axis, go up to y equals 1, plot a point, and then we can attach those points with a curve to get our y equals cos x graph. There we go. That's y equals cos x. Now we need to graph y equals cos 3x. Recall that when we have a b value, it transforms our x to 1 over bx. So in this case, x is going to go to 1 over 3x. We don't have any other parameters. We're just doing a horizontal stretch factor of 1/3 about the y-axis here. So then take each of our points that we plotted for y equals cos x and transform them by multiplying the x value by 1/3. The first point we have, x is 0, y is 1. If we multiply x equals to 0 by 1/3, it's still 0. So we still have that same point at 0, 1. Next point we plotted was at 90 degrees and the y value is 0. The y value is going to stay the same at 0, but the x value is being multiplied by 1 over 3, which is the same as saying being divided by 3. So 90 divided by 3 is 30. These are going up by 30, so 30, 60, 90. We would have our point would move to here at 30. Still a y value of 0, because the y values aren't being affected here, just the x values. Next one, we have x equals 180 and y equals -1. 180 divided by 3 is 60, so we'd have a point at 60 and -1. Then we have a point at 270 and 0. Divide 270 by 3, you get 90. So x equals 90, y is still equal to 0. And then we have a point at 360 and y equals to 1. Divide 360 by 3, we get 120, and y is still equal to 1. So it'd be 120 here and y equal to 1. We can join those points together. Then we should see that from 0 to this point, which is 120 degrees, is one full cycle, which means that P equals 120 degrees. Now we're asked to graph this function from 0 to 360, so we need to keep it going, but our points are just gonna repeat. So the next point would be at 150 and y equals to 0, which should be here. Then we would go over to 180 and y will equal -1. Then we go over to 210 and y will equal 0. Then we go over to 240 and y is +1, and we can join those. There's another full cycle, and then we keep going. Move over one to 270, we're at y equals 0. Move over another one on the x-axis, we go down to y equals 1. Move over another one on the x-axis, we get back to y equals 0, and move over one more to 360, and we get back to y equals 1, and join those points together to get the rest of our curve. So this is y equals cos 3x. And we could calculate our period algebraically by doing P equals 360 degrees divided by absolute value of the B value, which equals 360 degrees divided by B is 3. 360 degrees divided by 3, which gives us 120 degrees. Sketch the graph of y equals cos 1/3 x for x between 0 and 6 pi. State the period of the function and compare the graph to y equals cos x. Let's label our axes first. On the x-axis, we want to go up to 6 pi. So let's try counting by pi. If I did pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, that's too small. Let's try doing pi over 2. So 2 units would be pi. Pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi would get us to here. So that's going to work. Then for our y-axis, our a value is 1 for cos 1/3x. So we need to go up to 1. Again, I'm going to make each unit 0.5 so that 1 is here, so it's not so cramped. And then down here would be -1. Let's graph y equals cos x first. We should start to see a pattern. Cos x starts at 0 and 1 equals to 0 at pi over 2, equals -1 at pi, equals 0 at 3 pi over 2, and then it gets back to being 1 at 2 pi. But if you don't see that pattern, look at your unit circle again. At our angle, at an angle of 0, we have the point 1, 0, which tells us that cos at 0 radians equals 1. Then at pi over 2, we have 0, 1, which tells us that cos of pi over 2 equals 0. Then at pi, the point is -1, 0, which tells us that cos at pi equals -1. And then at 3 pi over 2, we have the point 0, -1, which tells us that cos of 3 pi over 2 equals 0. And then we just repeat that as we continue. When the angle equals 0, cos is 1. When the angle is pi over 2, cos is 0. When the angle is pi, cos is -1. When the angle is 3 pi over 2, cos is 0. And when the angle is 2 pi, cos is back to being 1. We can connect those points. This would give us one full cycle, and then it just continues. So in this case, as we move over 1 in the x direction, we go down to 0, then we move over 1 again and we go down to y equals 1, then we move over 1 to the right, we go back to y equals 0, move over 1 to the right and move back to y equals 1, and we can join those points. There's another full cycle. Do it again, move over 1 to the right, go to y equals 0, move over 1 to the right, down to y equals -1, move over to the right, up to y equals 0, and then over to the right, up to y equals 1. Join those points. And we have y equals cos x over a domain of 0 to 6 pi. Next, we want to graph y equals cos 1/3x. Let's find the period for this. Period is 2 pi divided by absolute value of b, which in this case is 2 pi divided by 1/3, absolute value of 1/3, which is 2 pi divided by 1/3, which is 2 pi times 3/1, which gives us a period equal to 6 pi. We know that our y values aren't going to change, just the x value that's going to change, but our period is 6 pi. The first point is going to be the same, the last point is going to be the same, but now this 0 to 6 pi, instead of having 3 full cycles in it, like we did with cos x, 1, 2, 3, we're just going to have 1 cycle. So we know that halfway between these 2 points, we need to go down to -1, and then halfway between -1 and +1, we need to get to 0. And halfway between -1 here and +1 here, we need to be at 0. So we can start using patterns to help us graph these sine and cos functions faster. Okay, so halfway between 0 and 6 pi is 3 pi. At 0 and at 6 pi, we're at +1, so at 3 pi, we need to be at -1. Then halfway between 0 and 3 pi would be 1.5 pi, or 2 pi over 3, and there we need to be at 0, halfway between -1 and 1. And then halfway between 3 pi and 6 pi, which is 4.5 pi, we need to be at 0, which is halfway between y values of -1 and 1. And then we can join our points together. And we get 1 full cycle of y equals cos 1/3x. Sketch using key points. Graph y equals 3, sine 4x, showing at least 2 cycles. The amplitude is the absolute value of the a value, which equals the absolute value of 3, which equals 3. To get the period, we can calculate the period by doing the formula p equals 360 or 2 pi. It doesn't say which one we need to be in, so we can choose. I'm going to go with degrees this time. 360 degrees divided by the absolute value of b. In this case, that's 360 degrees divided by b is 4, so absolute value b is 4. 360 divided by 4 is 90 degrees, so our period is 90 degrees. Our maximum is the absolute value of the a value in this case, since there's no vertical shift. So that would be absolute value of a, which equals absolute value of 3, which equals 3. The minimum would be the negative absolute value of a, which would be negative absolute value of 3, which would be -3. The x-intercepts we're going to leave for a minute. The y-intercept we're going to leave for a minute. The domain, there's no stated domain here, so our domain would just be x such that xer. And the range would be defined by our amplitude, since there's no k value, no vertical shift. So y such that -3 is less than or equal to y is less than or equal to +3 yer. To figure out the x and y intercepts, let's first graph the function y equals sine x. Y equals sine x has a period of 360 degrees, so we want to go up to 360. And this function y equals 3 sine 4x, we calculated it to have a period of 90 degrees, and we need to show at least 2 cycles. So if we go up to 360 on our x-axis, that's going to show more than 2 cycles, which is fine. I want to get up to 360. Looks like it's the same grid as before, so if I count by 30s, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Then I'm just going to write every third one here. So 30, 60, 90 degrees. Another 30, 60, 90 would take us to 180 degrees. Another 30, 60, 90 would take us to 270 degrees. And then 30, 60, 90 gets us to 360. Then our y, our amplitude is 3, so we need to go up to 3 and down to negative 3. 1, 2, 3, and 1, 2, negative 3. To help us draw y equals sine x, we can use the unit circle. Remember that sine is the y value of points on the unit circle. So at 0 degrees, we have the point 1, 0, which tells us that sine at 0 degrees equals 0. We can plot that point. When x is 0 degrees, then y is 0, which would be an x-intercept and also a y-intercept. Then at 90 degrees, we have the point 0, 1, which tells us that sine of 90 degrees equals 1. Find 90 degrees on the x-axis and then go up to 1 on the y-axis and put a point. And then at 180 degrees on the unit circle, we have the point negative 1, 0, which tells us that sine at 180 degrees equals 0. So find 180 degrees on our x-axis and then plot a point at y equals to 0. Then at 270 degrees, we have the point 0, negative 1, which tells us that sine of 270 degrees equals negative 1. Find 270 degrees on our x-axis, go down to negative 1, and plot your point. And then we get back to 0, which is also 360 degrees. So again, we get that sine of 360 this time is equal to 0. Find 360 on the x-axis and plot a point at y equals 0. And that gives us y equals sine x. Now we can use the x-intercepts and the y-intercepts of sine x to help us determine the x-intercepts and the y-intercept of 3 sine 4x. Using mapping notation, to go from sine x to 3 sine 4x, a point on sine x, xy, would go to 1 over 4x, 3y. So we'd multiply the x value by 1 over 4 and multiply the y value by 3. Then the y-intercept, which was 0, 0 for sine x, if we multiply that by anything, we're still going to get 0, 0. So our y-intercept for our new function is still 0, 0. And we can plot that point for our new function. Our x-intercepts of sine x are 0, 180, and 360 degrees. The x-intercept of 0 is not going to change because if we multiply it by 1 over 4, it's still going to be 0. So we still have an x-intercept at 0 as well. Since our y-intercept is 0, 0, we have an x-intercept at 0 degrees. Then our x-intercept that's at 180 for sine x, if we multiply that by 1 over 4, which is the same as 180 divided by 4, we get 45 degrees. And then our third x-intercept, 360 degrees. If we multiply that by 1 over 4, which is the same as dividing by 4, we get 90 degrees. And so on. So our x-intercepts for y equals 3 sine 4x are every 45 degrees, starting at 0. So then we can write the general form of this as 0 plus 45 degrees n, where n is an element of I, or you could just write 45 degrees times n, where n is an element of I. Okay, so it tells us that every 45 degrees we're going to have an x-intercept, which means halfway between 0 and 90 there's an x-intercept. At 90 there's an x-intercept. Halfway between 90 and 180 there's an x-intercept. And at 180 there's an x-intercept, and so on. Then we know that sine between the first x-intercept and the second x-intercept, sine x is above the x-axis and goes up to its maximum at 1 and then comes back down to 0 at the next x-intercept. Our new function doesn't have any negatives, so there's no reflections at all, so it's going to follow the same direction as y equals sine x. So between the first two x-intercepts, we need to go up to our amplitude of 3 and then come back down. Then for sine x, between the next two x-intercepts, it goes down to -1 halfway between those two x-intercepts and then comes back up. So we need to follow the same pattern. Halfway between the two x-intercepts, it's going to go up to the amplitude of 3, then it comes back down, then it goes down to -3, comes back up to the next x-intercept, and so on and so on. Okay? You could also calculate what your max is going to be. So our max here is at x equals 90 and y equals 1. I can use mapping notation. 91 becomes 1/4 times 90 and 3 times 1. Quarter of 90 divided by 4 is 22.5, and then 3 times 1 is 3. 22.5 would be halfway between 0 and 45. So halfway between those points and up to 3, somewhere around here. Then between the next two x-intercepts, we need to go down to a minimum. So halfway between those two x-intercepts is about there, and go down to -3. Then we can join those points together. And we get 1 period of our function y equals 3 sine 4x. And then we can just repeat the pattern. So halfway between the next two x-intercepts, halfway between these, we go up to y equals 3 and we put a dot there. And then halfway between the next two x-intercepts, approximately here, we go down to -3 and put a dot there. And then we join our points together. And there's two cycles. So we needed to show at least 2 cycles. We did. We have 1 cycle from 0 to 90. And then our second cycle from 90 to 180 degrees. And that is y equals 3 sine 4x. State the amplitude and the period of the graph. We have to find our midline. The midline happens to be the x-axis here from the x-axis, we go up 1 to the maximum. We also go down 1 to the minimum. So the x-axis is our midpoint, and our amplitude would be 1. We can use the formula for amplitude as well. Amplitude equals max minus min divided by 2. In this case, the max is 1 minus the min of -1 divided by 2. 1 minus -1 is 2 divided by 2 gives us an amplitude equal to 1. The period we can only do by looking at the graph because we don't have the value of b from a function. For reading the period from a graph, it's always ideal if you can start at x equals to 0, so along here. So we see that the graph has a maximum point at x equals to 0. If we go to the right to the next maximum point, we can read the x value, which is 2 pi over 3. That tells us that the period for this graph is 2 pi over 3. If you can't start at 0, you may have to do some adding or subtracting to find your period. But for this one, we have p equals 2 pi over 3. Amplitude of 1, period of 2 pi over 3. That brings us to the end of Chapter 5, Lesson 1.